Okay, so we are asked to form this committee of 4 people, right? CG chairperson, peer support leader, treasurer, and eco champion, right? So there's 4 people that you need to choose out of these 21 people, and you want at least 1 girl and 1 boy. So the way I like to do these questions is more from a complement point of view. That means we take the number of ways without any restriction, subtract away the complement of what the question requires. So if there's no restriction, right, and there's 21 people here, we need to choose 4 people from this, and then we need to subtract away all the combinations where there was only girls, and subtract away the combinations where there were only boys, because we're doing the complement here, you see. That means we need to subtract away those that didn't meet the condition to arrive at the final answer where we only have those which satisfy the conditions. So then we're going to subtract away 13 boys, you choose 4 of them. Subtract away the 8 girls, you choose 4. That means now we are subtracting away all the combinations where there's only boys, and subtract away the combinations where there are only girls. So if you key this in your calculator, you would get 5,200, right? Yes. Yep. Now, so some of you might stop here and say, okay, that should be the answer. But if you check the answer behind, right, or rather, if you know what's the actual answer here is 124,800. So how did we arrive at this huge number? I mean, shouldn't 5,200 be correct already? Oh, but actually you must think in terms that over here we're choosing a special committee where there are 4 named positions. We are not choosing a committee of 4 people out of these 21 people. We are choosing 4 particular positions. So the actual number of ways, right, should be 5,200 multiplied by 4 factorial. Because you can imagine that out of these 5,200 combinations, right, we can choose the first person. There are 4 choices for after we've chosen the committee, right? There are 5,200 ways of choosing this committee. Then for these 4 positions, right, the first position, let's say the CG chairperson, right, there could be 4 choices. So after you've chosen the CG chairperson, right, the peer support leader, you're left with 3 people to choose from, and there's 3 choices for the peer support leader, and so on. That's where the 4 factorial comes in. So when you multiply by 4 factorial, right, then you would get 124,800, which is the final answer. So let's just keep this going, just moving on. So if there's any more questions, please feel free to comment or ask me any question on any of my platforms. Okay, so then now we want to think about this class committee, right? So now after you've chosen these 4 people, and then we want to have the civics tutor to be seated in a row for photo taking. So if you think about this, now there are how many people here? There's a total of 5 people here. So the class committee, right, is these 4 people, and then there is another civics tutor. So I mean, I prefer to put them as boxes because I can draw boxes the best lah. No, you could draw a circle, you draw even a stick figure, whatever, doesn't matter. So if you have these 4 people, this class committee, this 1, 2, 3, 4 people, and the civics tutor. So if you want the class committee to sit in 4 adjacent places, right? So now we treat this as one block, and we treat this as another block. So of course we can switch this block in front or behind, which means whatever combinations we have later, right, we need to have the times 2 here. Okay, so now let's just think about this. So now we want a probability, okay? So apologies, probability that the class committee sit in 4 adjacent places. Okay, that means that to get probability, right, we always think about the situation where there's no restriction, right? So if there are 5 people and there's 5 seats to be filled, the no restriction way is just 5 factorial ways of doing so. So out of these 5 factorial ways, right, we want the class committee to sit in 4 adjacent places. So for this box you see here, right, these 4 places, for the first seat, there are 4 choices here out of the the 4 special positions, and then the second seat we are left with 3 people to choose from, and so on. Second seat 2 people, last seat 1 person. So this is where the 4 factorial comes in. Okay, the number of ways of putting 4 people into 4 seats. And then we must remember the times 2 that we explained earlier, because we could have put the CT in front of them, because when you look from left to right, this one would be like, how should I put this? This is like seat number 1, seat number 2, and so on. So it makes a difference whether the CT is in front or at the back. That's why we have this times 2 coming in here. So 4 factorial over 5 factorial, right? You can do mental sum also lah. So 4 factorial, 5 factorial is just 1/5. Because if you do all the cancellation, just 1/5. Then multiply by 2, you will get 2/5, which is the answer that was given at the back. So part 3 is a bit more difficult, so give it a bit more time. Okay, so I hope you had a bit more time to do part 3, because part 3 is a bit more tricky, and the answer is 310 if you're interested. Okay, so let's begin. And how do we get this 310? So now you want the civics tutor and the CG chairperson to be separated by at least 2 other persons. So my favorite way of doing this is to insert in at least 2 people in between them, because there are not so many people we are involving in this question. It's only 5. So some of you might think to do the complement, so we need to subtract away the number of ways where there were, where the CT and the CG chairperson was seated side by side, or there was one guy seated in between them. But here it doesn't really matter, you see, because if you do the complement, it's equally complex. It's almost as complex as doing what the question wanted you to do, which is at least 2 people seated in between them. So how do we think about this? So let's say now we do the CT here, and then we have 2 other people inside, and then we have the CG chairperson in this box, okay? And then there is 1 other person here, okay? So now that we've taken the CG chairperson out of the 4 people committee, right? There are still 3 choices left for this seat, 2 choices left for this seat, and 1 choice left for this seat. So the thing here to understand is we are going to treat this entire thing as 1 block. Why? Because no matter what, right, we want the CT chairperson and the CT and the CG chairperson to have 2 people seated in between them. So no matter what, these 2 we cannot take them out. So that's why we consider that 4 people as 1 block. So that's why we have blocked up this 1 block and another block. So what is the number of ways for this? So this one, let's just wait for a while. So let's also understand that this CG chairperson and this CT can switch around. So we need to say that, the first seat could have been occupied by the CG chairperson or the CT. So that's where the times 2 comes in. And also here, right, we can also switch these 2 groups around here, which means these 2 groups, right? Sorry, apologies. This 1 person could have sat in front in the first place. Okay? So either in front or at the back, because when we look from left to right, all the seats, it makes a difference whether this 1 person is seated at the first seat or at the 5th seat. It's a different arrangement already. So that's where there's another times 2 here lah. So over here, the number of ways was, so the number of ways for this arrangement would be 3 factorial, which is what we have in red, the 3 factorial, multiply by these two arrangements when we flip them in front. Sorry, the exchange position of the CT and the CG chairperson, and the one where the odd one out was seated in front instead. So 3 factorial times 2, so 4 times 6, you get 24 ways here. Okay, 24. Okay, so the question is separated by at least 2 other persons. So you could have the situation where they were separated by 3 people. So let's just draw something simple for that. CT, 3 people, and then the CG chairperson. So over here, because we want this to be separated by 3 people, right? So this is one entire block in itself. You know, we can't switch the 3-person block in or out of this red box now. So you see, it must, this CT and chairperson and CG must have 3 people in between them. So this one, right, we have 3 choices here, 2 choices, and 1 choice here. Okay, and again we can switch the positions of this around. So that's where we have times 2. So the number of ways here is simply 3 factorial times 2 gives us 24. Okay, then finally we want the probability to answer the question, and probability that the CT chairperson, probably that they are separated by at least 2 people would be the number of ways where they are actually separated by more than 2 people, which is, sorry, my apologies, this one is 6 times 2 is 12. Okay, 12. So the total number of ways will be 12 plus 24, 36 over 5 factorial over 120, which gives us 3 over 10. Okay, so that's a very quick way of trying to explain this. So if we had more time, or we have tuition together, so there's more room for discussion and so on. So I'm going to end my video here. So if this video helped you, please like and subscribe and share with all your friends. Any comments are always welcome. Thank you.